movie. I mean, like production type thing, right? Let's just try to imagine that. I mean, I hope a year from now, or even less, that will be the story. Or maybe actually today. Well, let's take a look at, first of all, the motivation. Why would you want to use Kubernetes in the first place? Just to recap why we're all here today. Secondly, well, there are some barriers to adoption. And we'll look into some of the details of those. And then I'll walk through the experience that our team had bringing up Kubernetes in production in EC2. And show you the tools that we've built that make our deployment much easier and more reliable. And hopefully I'll have enough time for a quick demo. All right, well, let's start. How many of you are hearing this from your boss? I bet quite a few. You really need to deliver software features faster these days. And that's what every organization really wants. The engineering team sat down and put their brains together and thought, well, everyone's talking about microservices. We should definitely do that. And then they hear about containers. Well, microservices and containers totally make sense. You now have this ton of software that you got to ship, and you got to package it in some sort of a standard fashion. And sometime during your journey, you discovered Kubernetes and realize, well, that's probably what you need to run the microservices in containers at scale. So the promise of microservices is that you're going to develop faster. Teams can work on different projects, use completely different languages or frameworks. Cool. You can move fast. The promise of containers, that you'll get reliable deployment for those fast-moving pieces. And with Kubernetes, you'll get some additional high-level tooling for scaling the services and ensuring that your compute resource utilization is at the appropriate level. And most of the people in this room will agree with you that these are all great tools in theory. However, in practice, there are still quite a few questions, and I do not believe that too many of you have already stood up a production cluster that they're totally happy about. More questions arise because all of us have opinions, and we cannot take too big risks. And we also have legacy systems. If you really don't have one, I mean, lucky you. I've only been in this job for a year and a half. There are legacy systems already. And it's a startup. Let's see what these questions are really. And we break them down from bottom up, starting from, well, yeah, actually, while we're going through this, you must deliver faster, don't forget that. Languages and frameworks. In the microservices world, you really have the choice for using the best tool for the given application that you are building today. I mean, the given part of that application that you're building today. And each team can use any framework or language they like. They go and code their app. Then they'll probably use Git and CI or some other revision control system and CI. And they'll write some tests. They'll configure CI. Excellent. If they want to push that into Docker registry or some private registry of other sort, that's a well-supported feature in the CI systems that there are. Excellent. We're doing well here. Next, the infrastructure. Well, from the point where you've built the container in CI, you really want to push it to a cluster. And once you're here, you probably want to use Kubernetes. And creating a Kubernetes cluster is fairly easy for quite a few people for the first time. You just download the shell script, you run it, boom, it's done. You set the cloud provider, you didn't like GCE, you run AWS, cool, excellent. All pretty sound, except when it comes to opinions and non-trivial requirements. We had a few examples, I'll walk through those later. Next, the shipping pipeline. You want to configure, you've built your application in CI, you set up Kubernetes, and you want to ship it from CI to Kubernetes continuously. Well, that's fairly doable, but a lot of things are still to be understood. And hopefully the next release, 1.2, will make that easier. But still quite a few things for you to figure out when it comes to your own application, because your story may be a little different from everyone else's. And on the daily basis, you want to make sure the system is up and running and scale when you need it and do that in the right time. What are the best tools for that? Sorry. I might have a few hints later on. Anyhow, this is all theory, and let's quickly summarize that. We've gone through 5 steps, which are about the app, the build, the cluster, the deploy, and the execution. That's what we call ABCD of microservices. Well, that may be excellent theory, but you really, really, really need to get delivering faster, right? I kind of mentioned infrastructure in one of those steps. And I said, yeah, it's hard, and there are more opinions in infrastructure. So let's kind of go through those. Because that's the first barrier we hit, right? So we'll talk about opinions and risks. It's more about opinions and a little bit about risks. And sometimes opinions are based on risk evaluation. Okay. So first of all, once you enter the Kubernetes world, you will hear a lot about all these new and shiny toys that you might really like. But will your boss let you deploy all that stuff? Or really will you let yourself run all the new things all at once? Is that a great idea? Some of us, maybe. For example, you often hear about the new operating systems that are designed to run containers, and I personally love those, but I know for 100% that there are many organizations that will buy into containers, will buy into Kubernetes, but they really want to use the OS they're familiar with. Automation tools. Okay, well, maybe here you kind of like, well, I kind of really want to ditch that old thing I've had forever, that like, whatever that's called, really don't want to be using that anymore, and I want to try something new and fancy, and you know, I've played around with it for about a year or two at home, and I really want to bring it to work. Let's say it's something like Ansible or Terraform, or maybe you want to use both, and if you do use both, where the boundary comes in, who does what? I mean, these are all interesting things, and there are risks and theories around that, and you know, immutable infrastructure and non-immutable. Which one do you want to do today? And then the cloud provider, you got to choose that. And now you're like, oh, Kubernetes kind of works better in GCE. Maybe I can convince everybody to move off the other thing that we've been using, because they're not exactly happy with the bills that we've been getting lately. Maybe I can just about convince them. Well, maybe you won't, who knows. So cloud provider is a big deal as well. And well, yeah, with Kubernetes, or containers in general, you kind of tempted to think about, if you're running your own data centers, maybe now I can switch to bare metal, because containers are more efficient, and maybe I save some money. I don't have to pay for licenses for that virtualization thing that I've been paying for so long. Right, but then I also kind of like the tools that this thing gives me. It may be expensive, but I get this nice abstractions. So you can pondering around that for a while. Hard to decide, right? That you really need to start delivering faster. Do I have that slide again? Not yet. And yes, you started up Kubernetes, and you totally like almost running it in production, and you're thinking, well, should I now pay for commercial support? And who are the vendors that I should be talking to? Is it going to be one vendor, or is it going to be a couple of vendors? Supposed to get etcd support separately, or how do you do that? A lot of questions there. And then cluster management, how are you going to actually do things with that? Is it going to be immutable, or what is it? How are you going to do in-place upgrades? If you need a new release of Kubernetes, are you going to allow yourself to take down the whole system, or you should be doing sort of semi-zero downtime kind of deployment when you're upgrading the entire cluster? What are you doing there? All very interesting questions, and I'm sure many of you will have many opinions around there. And then, yeah, how do you actually troubleshoot the thing if it goes really apeshit and you didn't buy the commercial support yet? You really don't know what to do. So you need to know the basics at least. So many questions, yeah? And actually, by the way, how do you run the databases? Are you going to use a database that's been running there forever, or are you going to Dockerize that? And somebody's asking you about access control, and you just read that there will be LDAP plugin of some sort, or Active Directory one, or whatever that takes. But it's kind of new, and you only seen a pull request so far. Is that actually really going to work? And what is it really going to mean? So, yeah, tons of stuff. And the last thing, you kind of thinking, well, I've heard all this. Maybe I should just buy a PaaS. There are PaaSes that are based on Kubernetes. I might just want to buy one, or they're open source ones, and it's great. Okay, you have to evaluate that now. Okay, well, why these questions coming up? Because Kubernetes is really a large system. Really? Well, yes, it is. I mean, just the cluster itself will have this kind of set of components where you got the etcd for persistence, you got the API server here, you got the controller manager and the scheduler, and you still to figure out how you're going to do HA around that. 1.2 has some promising features, that's great. And then you got connect your kubeproxy and kubelet to the API server. Yeah. You're yet to decide what the sizes of these instances, what is going to be the capacity you need to run this stuff alone without the application. Yeah. And what kind of storage etcd requires and such things. And you hearing about an overlay network that you supposedly need to use. And you kind of not sure what's the whole debate about L2 versus L3. What is that all about? I mean, maybe you heard of it before. Maybe your colleague explained it once, but you forgot again. And you wish there was just a product that simply works. And then storage. And you kind of wonder, well, they talk about software-defined storage. I'm really not sure what is that. I need to read up on that. Maybe try that on its own, and that's going to be another research project for you. Excellent. You got yourself a ton of questions here. And how are you going to do monitoring? Are you going to buy a product that integrates with Kubernetes? Maybe. But you need to look at all of those. And you might also want to run a private Docker registry. That makes sense. Okay, that would be part of that picture. And we are delivering faster. Not quite. We've been thinking for quite a while. I mean, it only took 20 minutes, but imagine what it would take in practice. Okay. So here's our team's experience. We really wanted to build something quite simple. It is the service that essentially the back end of our monitoring platform that is open source, and we run it as a service. You can try it out. I'll give you a link later. The product is called Scope, and it comes in 6 pieces right now. Simple Go programs. No messaging, no fancy databases, nothing like that. We have RDS and HTTP APIs between these services, all very simple. But we need to deploy it at least in 2 places, on developer VMs and in production. A couple of clusters in production, and we want that fast and reliable. We've used tools like Terraform for a while. We really like those. Kubernetes Upstream doesn't use Terraform right now. And looking into that, turned out to be quite complicated. and on its own, just like replacing kubeapp sh with Terraform. And you're still going to use Salt, or what are you going to do? And yeah. So, I mean, we tried a few different approaches. I have done some early research before we even had this project, running Kubernetes in Azure, and implemented that. That was way early on, and we also tried a few local deployments on Vagrant and Docker Machine and such things. One of the things we found is that obviously not all cloud providers are quite the same. They all have different feature sets, and a bunch of things just don't map the same way. Or certain things are just like slower and not as easy to use. Like one of the good examples is that in Amazon, ELB takes 5 minutes to come up. Well, I mean, you created your replication, sorry, not replication control, your service in Kubernetes creates an ELB, you get that, but I mean, your service is actually deployed much faster than it takes for ELB to become available. So never delete the service, unless you really have to. Change your replication control the way you want, but keep the service there. If it's using ELB, it'll take you a while to bring it back up. That's one of the examples. And yeah, actually, we also noticed we used RDS. It's like half an hour to come up. I was very surprised. Because now things are so fast in Kubernetes, you know, it's like RDS takes half an hour. Jesus, slow is that? Setting up from scratch is it's quite hard. Some of the things not documented amazingly well, and I hope they will get documented very soon. But I mean, why should you really have to do that? And the especially hard part is like when you have to set up the certs and all the things. It's just quite a bit of work. Some people done it. There are projects on GitHub. They've done it. They've got their stuff packaged in a certain way they want it. It runs on a given distro. It runs in a given cloud. I mean, it's got some kind of set of opinions built in. But everything that we looked at was didn't quite fit what we wanted to do. Like, it would run on Red Hat, but not on Ubuntu. It's like a great project, but changing the distro apart is maybe not as easy, and then we kind of didn't quite like some of the provisioning tooling, and we wanted the others. Anyway, we also looked into self-hosting, because that's the promise. We're supposed to be able to deploy everything through kubelet. Unfortunately, like I and my colleague had 2 hours conversation, and we couldn't quite come to terms around it. And it's like, it was really hard to reason about. What does self-hosting actually solve? It's a great proof of concept of how things could work, but in its current shape, it's hard to reason about. It doesn't seem to make much things easier. And yeah, again, operating systems and configuration. I love Chorus, I love Atomic, but the team are very comfortable with Ubuntu, and I have no problem with that. I mean, but let's just get all the boring operating systems supported. Just kidding. So, and we really like declarative provisioning, as I said. Terraform is amazing, but then don't have to use it. And essentially, the key to our approach in Kubernetes provisioning is use our own product, which is open source. It's called ViewNet. It gives you an overlay network, very simple to set up, doesn't require key value stored in the first place, so you can run etcd on top of it. And it gives you DNS right out of the box, so you can assign fixed DNS names to each of your cluster components. Your API server now has a DNS name, and that's how you're ever going to know it. You don't have to look up an API address of the API server, figure out which one is what. So that's the approach we've taken, and what we've built is called Kubernetes Anywhere. It's very easy to set up in any cloud, whether it's local, bare metal, whatever. And here's a link to the project on GitHub. Take a look at it. There are a few examples. One example uses Terraform and EC2. There's a good Docker machine example that works with VMware, VirtualBox, and DigitalOcean. If you ever wanted to run Kubernetes on DigitalOcean, that's probably the easiest way to try it out. And yeah, take a look and see for yourself. It is a very simple and robust way to provision Kubernetes in any environment. And you can scale out your cluster without changing any configuration. And you can actually implement in-place upgrades because all of the components are Dockerized. So you could just do a pull and restart, for example, or whatever you fancy. It's pretty easy to adopt. There's a very thin layer of Kubernetes Anywhere project itself, and there are a couple of examples that show you how you could run it using different tools, whether you fancy Salt or Ansible, or just want to write some shell scripts and use Docker machine or anything like that. Totally fine. You can even set it up manually. It doesn't take too long. And yeah, one interesting aspect is it also implements security, and the PKI is containerized. And that's an interesting one. Probably blog about it later on. So we could potentially actually implement fetching of the certs from the Amazon's new certificate manager if we really wanted to. Because the certs are provided by containers as volumes. So you could run something before you pass that on. Yeah. And as I said, we're using Weave for bootstrap and management and pod networking at the moment as well. We're looking to implement CNI, and then you could drop another network into it. And by the way, we're releasing a ViveNet CNI plugin very soon. If any of you familiar with networking side of things like CNI, does that ring a bell to anyone? Not going to go into details about that. There are probably some networking related sessions later if you want to find out more. And yeah, the key is to use Vive DNS and Hypercube Docker images. And you just pick a couple of Docker hosts, launch Vive, pick your master machine, your etcd nodes, and off you go. So let me see what time I've got. How are we doing this time? We got 10 minutes? Cool. All right, I'll do a quick demo. It's all local. I'm not using the cloud. I've had issues with the Wi-Fi here. So let's jump out of this. Right. Okay. So what I got here, this gets smaller. Let me resize this. Okay, great. Obviously, I didn't realize this is going to resize. Screen settings, mirror. Okay, well, that's much better. Okay, so here's, oops. Here are the few commands I'm going to type in. We just rebooted these nodes and we're kind of starting clean. It's all offline. So it should work, right? Really, but I mean, I'm still praying the demo gods and all that. So I'm starting up one node and another. Just looking, using a couple of boot to Docker VMs here, using Docker machine. These shell scripts are pretty thin. If you want to take a look at that, I can show you that. I just didn't want to type too many things into the terminal right now to avoid making typos, so I'll wrap that in scripts. Okay, so we've got two toolbox containers. One is not quite there yet. Okay, so in this one we can look at Docker PS. So there are a few containers running on one host. So I've got a container on one host and another container on the other. Okay, well, obviously it's a demo. Mhm. That was a little bug that I've been hoping to avoid, but we happen to hit the bug that I've been hunting for a week now. Seriously. I love it when it comes to demos. Okay, well, I'll have to record this, but sorry about this. Making a couple of typos here. Okay. Okay, there we go. Okay, cool. Compose. So I'm going to run Docker Compose here to bring up the master components all at once. So here the first step. Okay. Kubectl get nodes. No nodes yet. Let's watch for nodes to come up. Okay, cool. I've got one node here. Excellent. This is node 2. Somehow started with a node 2. Okay. Right. And I can create pods. I need SkyDNS add-on. This is kind of from scratch setup. Okay. And I'll just deploy the simple guestbook example. So they're pending right now. Can wait. They're starting up. Cool. So, okay. Are they all ready now? No, a few still pending. Okay. Okay. Okay, everything's running now. No, not quite. Ready slave is starting. In any case, so we can get service frontend. And yep, it's there. Describe to get the node port, because this is using local VM, so using node ports. Okay, we got the guestbook here. Some people thought it was KubeCon. Oh, ready slave is not coming up yet. Okay, still. Okay, well, it's somehow taking slower sitting here than it was there. I would mind to start taking any questions anyway. People have questions so far? Right. Okay, so it's yeah. Let's go through that totally. So I got a bit distracted with part of it not working exactly as expected. So I fired up one node here, and I've dropped into a container, and I ran Docker Compose. There's a compose file here. I can show you that. So this is the compose file I've deployed. Can you all see this? Okay. So it really just starts a few containers. Include that CD, API server, scheduler, controller manager, kubelet, and proxy. So it starts the master containers and the work containers all on one machine here in this instance. Yep, done that. I've used Compose to deploy it. Then I've gone and done kubectl get nodes, which shows me that one node came up. And I've done kubectl create SkyDNS add-on, which creates the cluster DNS add-on. And done create guestbook example, and which was the guestbook that we just saw. And then yeah, essentially we can look at pods and all the namespaces because the all namespaces. Okay, now they're all running, right? So you can see that SkyDNS add-on is in kube system namespace. That is required for the app to function. Okay, well, this should work. Hello. Boom, it works. We reload the page. Hello. Boom, again. Okay, cool. And the next part of the demo, I was going to add a second node to this cluster and scale out. Does that make sense to everyone? Okay, because I mean, there are a few examples on the internet where you can use Compose to deploy a single node cluster, but here I'm actually able to add nodes to it without any extra faff like passing API server IP addresses around and such things, because I've got the Weave DNS for the API server. So I had a kind of weird issue here that somehow the demo decided to not work as I expected once I moved from that chair to here, literally. Docker machine SSH node 1. Okay, Docker PS. Docker run. Can we see this? Yep. All the event. And cut. It is the KubeCon boot local demo. So I need to run this. Which bit? This one, right? Weave status DNS. Let's just double check that. Okay, so you can see the entries in Weave DNS here. That we've got a etcd1, Kube API server, Kube controller manager, Kube scheduler, node 1 and node 2, and the toolbox. Yeah. Okay. Obviously something's gone wrong here. Yeah. I need to run one of these commands. Yeah, this guy. Oh yeah, it's the other one. KubeCon node 1. Okay. So I need to run this. Docker run that. Okay. Just double check that because I'm trying to figure out what's gone wrong at the same time as well. And that's fine. Okay. And now I need to create the. So I'm going to create the kubelet container and the proxy. Those are the two main processes a Kubernetes node has to run. So I'm starting the kubelet container with this command and the proxy with this command here. Yeah. They're all running. And now I can go back to here and I can look for the node to come up. So I'm doing kubectl get nodes. There's only one so far. Wait, this does take a little longer. Yep, now it registered. So we can see the second node join the cluster. And kubectl, right, so right now we had a single node cluster and we started some pods, yeah? So to convince ourselves that they're all running on the same node, we can run kubectl get pods output wide, and that prints the node name here in the last column. It normally doesn't print the node name, by the way. You need output wide. And we can see that there are 3 front ends, right? And we can scale them up. Let's make them 6, double up. Okay. And now we do that. And then now there are now few pending on node 1. Yeah, like this one, for instance. Still pending. Should come up shortly. Anyway, this was pretty much the end of my demo. Well, there's one last thing I can show you that well, if I do Docker machine ls, so I've got 2 VMs here running on .158 and .158 and .159. So I early access .159 using this port. I should also be able to access the same app on 158. Boom. Hi. And if I go to 159 again, see the same thing. Okay? So after all, managed to fix it. But let's take a look what the problem was. Thanks so much. In any case, I'm just hoping that you might be potentially a little closer to delivering faster. Whatever is that you're going to do? Are you going to use Kubernetes or do something else? Or use a hosted version, maybe? That could get you moving faster too. And yeah. Okay, well, I'd invite you to sign up to our monitoring product here. That is actually what we run on Kubernetes in EC2. It's at scope.weave.works. We're accepting early signups now. If you want to note down the address, hopefully easy to remember. You can follow myself on Twitter. I'll tweet this deck later if you want to share it with anyone. And links to the Kubernetes Anywhere project. And we're also releasing ViewNet 1.5 shortly, which will come with a CNI plugin. So if you do run Kubernetes and you're looking to try different networks, you would be able to try Vive as a plugin on an existing cluster. And we're also sponsoring a party tonight. You should have some tickets for free drinks in your goodie bags. If anybody didn't pick up a goodie bag, take a look. Yeah, thanks very much. Oh, I had a backup slide. Thanks very much. Do we have time for any more questions, or if people have questions, do we? Okay, please, 1 or 2 questions. About anything. People just want to go for lunch, I guess. Thanks very much, everyone.